Modern data centers are being built in completely different ways than the traditional data centers. And in order to cater to the high traffic demand between the servers, you have workloads like Hadoop and AI/ML, which has completely transformed the traffic load characteristic from north-south to east-west. So what ended up happening is you now build networks which are extremely dense, which runs layer 3, and the number of units that you have to match and you have to track and operate, like the links and the optics and the silicons, it is multiple folds than traditional data centers. And the other transformation that has happened is the traffic between any two servers can go over hundreds and hundreds of paths, and every link is shared. So if you have a defect on a particular link or optics or some gray failure somewhere, it is extremely hard to kind of pinpoint and take care of it. And essentially it manifests as some application problem, which is a slow bleed problem. And so running basically a proper network with the new modern data center architecture is a challenge in certain ways. So the main challenge that comes in is if you go with the traditional NMS systems, they are based on regex matching or some rule sets and stuff. And tons of noise floods into the alert console. And it's really hard for people to manage pages and pages of alert and then manage all these issues. So you have to bring in some technology where you can basically zero in the noise or make the signal to noise ratio really strong and really identify the root cause and then go after them and fix it. So I think the lack of the capabilities in the traditional NMS, and where we have used AI/ML, and later on we are going to talk about it, is where the challenge has been and where the solution has been.
We serve lots of banks and financial institutions, and any second or even milliseconds of downtime, it's a huge deal. Can have serious consequences, not just financially, sometimes even goes into the legal and brand space. So that's a must for us, and it's one of our differentiators.
For networking, which is the topic here, as we talked about, as well as data center, we're teaming up with one of the companies we're teaming up with is Octera, where we have the AI ops tools, and we use that along with all the different software stack we have, Sonic, etc. In a multi-vendor environment and a multi-software stack environment, it's not possible anymore to troubleshoot the network or even understand the visibility. You have to use these kinds of tools to be able to get data from multiple layers. You're able to abstract layer from the silicon layer, from the PCIe cards like SmartNICs. You want to be able to get it from the software stack, from the operating systems, from both traditional OSs and next generation management tools. And that very complex task to look at all the layers and decipher it into observability and isolate events is only possible with AI ops tools.
This is what our strategy has been. So we quickly figured out that, hey, we cannot be in the incident response business or incident management business. We have to be in the business of incidents prevention for the application. So we actually double down on how do you run a clean infrastructure. And when you say clean infrastructure, like exactly like you have said, like it depends on what dirt you see, and it depends on your visibility on the amount of dirt that you see. So you have to run an infrastructure where you get all the dirts out. Basically, you have to have that visibility in all layers. But the challenge is at the same time, you cannot get drowned in the noise. So you have to get the signal out of the noise and then fix it. And possibly if you can predict the actual defect coming in, you fix the defect before the defect shows up. So what we have been doing there is we have AI/ML logics and systems put in our network, and we basically focused on making sure we catch all the signals, and we basically any link error for that matter, we fix it before even an application situation comes in. And that has been the focus, because the traditional one is based on the telco system where a link goes down and they track and fix it, and that whole traditional thing doesn't fit in our data center ecosystem anymore. So that's where the focus has been. And, we have been pretty successful, and it's an ongoing journey because you fine tune the system. And, for example, for syslog matching, you cannot really depend on the regex matching because it's going to be the first time a syslog is going to come in and that's going to melt your network, or hurt your network, and you don't have a regex because by definition it's the first time, right? So with AI ML, we have the rate of syslog getting ingested and a lot of other vectors which can really help us predict the problem that might be showing up. And we have been pretty successful in running that.
And worse still is if your reaction is to a customer call as opposed to you proactively discovering it. Which
yeah, we hate the customer calls.
And I'll mention just one SD-WAN. Now they have a level of sophistication. You can control traffic at application level without necessarily knowing what the actual content, the final content of the application is. So traffic steering and visibility at application level is fundamental to bring these services to market, and that's what enterprises require. Today, there is also a lot of customers wants to have much more control on the service, and so it's not anymore a black box. They're willing to let managed service provider to manage the service, but however, they want to have the tools and the knobs to be able to control the service. So applying visibility at the application level is fundamental. So now back to the question, what does AI do in this space? We are able, and actually here I've also mentioned Auctera. We've also been working with them, but also with other companies. You're able with this technology to pinpoint anomalies, as an example, and show this information back to customers. Not just about using AI for us, but also exposing it to customers for their own use. You can decide what to do with it. You can put in place a closed loop automation if you want. At the moment, we were thinking about providing it to customers, a visibility tool, and as an added-on layer for customers to have incremental information regarding what's going on and decide what to do with it by themselves.
Hello, I'm Jean-Louis Leroux, Head of Global Wholesale and Enterprise Network within Orange. I'm sorry I could not be with you today, but I really wanted to send you this message. We are convinced that artificial intelligence is going to significantly improve and transform our network management. This is why 1 year ago, we deployed the product of Auctera Networks to determine how artificial intelligence and machine learning could help our network design and operation. We selected Auctera for their powerful network and machine learning skills. The first use case we have implemented is to detect what we call gray failures before our customer can detect issues. Those failures are very difficult to detect by our operation teams. The platform has been deployed for a backbone of 1,000 routers and has shown very interesting results on anomaly detection. We have detected several important anomalies, such as traffic loops on service cards, and they were detected before any customer impact. There is increasing relevance for machine learning as we apply it closer to services where the noise from network signals and alarms is massive. And this is why we will progress now with SD-WAN service monitoring use cases. We will extend as well the usage on our international networks with 270 POPs in 100 countries.
So what we started with was, okay, we knew that there is an opportunity coming, and it's almost 2 years back. So we said that, hey, why don't we just fit the data into this AI system and see what it can do for us? And can it really detect the anomalies? And can it really give us a really strong signal and without all the noises and stuff? And we basically just had a console on the side of our traditional alert management console just to see the parity. Is it finding something which we are not finding from the alert console? Because you have to first test the system. So what ended up happening was we found that the AI ML technology really works well in gathering the data. You have to normalize the data, aggregate the data, deloop the data, and then there are all the steps that are there. And we found out that it really is picking up the data that is strong signal. And then the question was, hey, if you are getting the strong signal, why throw it into a console in pages of console and have the NOC engineer pick up a alert and create a ticket if it is really solid? Because what happens there is you have all these alerts showing up in the console, but nobody kind of tracks when it got shown up, when it showed up, and when you fixed it, and when you mitigated it. All the mean time to detect, mean time to mitigate, and mean time to restore, those numbers go out of the window because you have it sitting on the console for days at times. So what we ended up doing was we basically made the AI/ML system the core of the system, and we said that, hey, why don't we just use the signal and directly open up a ticket in our ticketing system? So there is no console business at all, and we know exactly when the defect started and what did we do to basically mitigate it, and later on you have to restore it, right? So in our journey, we have actually developed confidence in the AI/ML system in a way where we are actually pumping it directly into our ticketing system. We have integration with the ticketing system, and now we know that, hey, this error started showing up at this time, and how long did we take to fix it, right? So it's been a journey because you have to constantly fine tune some of the systems, and you need good people to kind of put it together. So that's for sure, but it has been really helpful to us.
And you need to equip your operations to be able to help the customer make good use of it. We spoke about closed loop automation. That's one way to do it. If you are willing to put in place automation, maybe for simple tasks, but in general, I think it's open loop automation. So something comes out from the system, detect an anomaly. What do you do with it? The customer needs to know, need to decide what to do, and it's not one single option. You need to break down problems into smaller problems. I think if you think about, you can detect faults in the network on a service, you will realize that first maybe you can detect some problems for a certain subset, for certain type of alarms, and then you build up on that. So it's a question of expanding from a core initial application into making it bigger and bigger.
So the question is, hey, can you show a real practical example how AI/ML really helps? So, one practical example is just think about error rate on a particular link. If you set a threshold for those error rate as a very low value, 0.01 or 1, your basically console and the ticketing system will get flooded. If you set it too high, it's basically not going to catch anything. And so basically, and the links are 100 gig now. So even if it is 0.5 or anything, you are dropping a bunch of traffic anyway. So once you throw in AI/ML logic there, you have a lot better understanding of what is the steady state, the historical behavior of the network. And when something actually behaves in an anomalous way, it pops up and you directly go in to fix it. Of course, the idea is to clean the network completely from any error rate, but one of those examples there. Once you detect it, what you do with it is very important. So basically, if you detect that, hey, this link is having error, or this switch is doing black holing of traffic, and you want to cost out the switch from the forwarding path. Now, the question is, if a human being has to come in, be it NetOps, whatever, and put in the configs on both sides of the link or the devices or whatnot, it takes tens of minutes or even hours to take care of it. And what happens is during that time, the application is suffering, right? So the question is, how do you automate those changes when you see those issues? And this is where the organizational functions has to come together, because that change automation is driven by how you manage the life cycle of configuration on a device. And it goes back to how you design the network from ground up. So all the architecture, engineering, as well as NetOps discipline has to work together to make it happen. It cannot be an afterthought in NetOps where they just automate some change management and say that, hey, we auto remediate, because network configs just drift out. And now what you thought that this config would work, you stamp it on the router and it actually doesn't, first of all, it doesn't show any difference, or better still, it can actually hurt the router, right? So these things are all connected back to back. And so from a functional change point of view, everything has to be looked in its totality. You cannot just pick up the tail and say that this is an elephant or whatnot. So, that's basically the change that it is driving. But we do have a lot of data, how we basically track, hey, what was the mean time between a major failure or an outage, and an application had to come back to us saying that, hey, we are seeing this degradation and this is due to network, find it out for us. With our way of searching the issues and getting it fixed, searching the issues using the AI muscles and getting it fixed before it becomes an application issue has been working. Like all the data are showing that our mean time between the incident has gone up at least multiple, like 3 to 4 times at least. So basically, I don't get called. Like, of course, there would be escalations and stuff, and you have to basically give them the help they need. But in many ways, it's running a lot cleaner than what I used to run with traditional LMS systems.